number 4 is a little bit more complicated, but basically the same principle. So I'm trying to solve for b. There's a lot of stuff in the way of b being by itself. So the first thing I want to do is get rid of that fraction. To clear a fraction, you need to multiply by the reciprocal. So that's going to give you 2a is equal to h times a plus b. And, normally we would distribute that h just because every time we see a parentheses, we want to distribute it. But that's actually not the case here. You don't always want to distribute something. And in this case in particular, if I just divide by h, that's going to get rid of it on the right-hand side. So I'll have 2a over h is equal to, and now that the h is gone, we actually don't even need the parentheses, and I have a plus b. So then my last step is going to be to just subtract a from both sides, and I have 2a over h minus a is equal to b. So it looks like a mess, it kind of is, but this is the formula rearranged for b, so that is our answer. Number 5, also kind of a more complicated one, and I'm solving for a. There's a ton of stuff here. I'm going to kind of work my way from the outside and get closer and closer towards a. So I'm going to subtract vt from both sides. So that is s minus vt is equal to 1/2 a times t squared. And let's get rid of that fraction by multiplying by 2 over 1. And you do actually need to multiply the entire side by 2. So it's your choice if you want to distribute it, or if you just want to leave the 2 on the outside, that's fine as well. But that will eliminate it there, and I have a t squared. So the only thing that's in the way of a being by itself now is t squared. And even though there's an exponent with that, I can still just divide both sides by t squared. So I'm going to have 2 times s minus vt. Again, it's up to you if you want to distribute that 2 or not. And it's over t squared, and that's equal to a. So very complicated formula, but we have rearranged it. We have solved for a.